Hello and welcome. My name is JP Metcalf, and today we are going to find the newest ENVI tutorials for ENVI machine learning, specifically supervised classification. And the way this works is it'll be like a follow along. I'll do it as if I've never seen it. And in fact, I've never seen it. It's brand new. Came out in around the end of October of 2022. So with that, let's get started. Let's go to the L3 Harris Geospatial website, find those tutorials. So I'm going to type in here, L3 Harris Geospatial. And then since I've been there a lot, I have an address in there. Brought to the home page, and I'm going to look for support at the very top. And then under self-help tools, if you hover over it, a little breakout's going to show up. And then I'm going to find tutorials. Okay. Like I said, yeah, brand new. It says the first one, ENVI Machine Learning Tutorial, Supervised Classification. It came out in October 31st. That's about 2 weeks ago. And I know a PDF is going to come up. So what I'm going to do here is I'm going to hover over it. At the very bottom, I can see Supervised Classification PDF. I'm going to right click and say open a new tab. And then I have Adobe Acrobat Reader, so it's kind of like a plugin for Chrome, so it looks a bit different. And then I want to get rid of some of this stuff over here and maybe zoom a little bit. That's too far. Okay. So a little bit of information. In this tutorial, we're using ENVI Machine Learning. We're going to train a supervised classification model to find specific features in an aerial image. We'll learn how to use the ENVI modeler to create a reusable workflow. Training rasters and ROIs will be used, so those will be provided. We can use those to train a model suitable for classifying similar imagery not used during training. Okay, so what that means is we're going to train a model and then apply it to imagery that we're not trained on, right? So it's we can apply it to a much bigger data set. It talks a little bit about system requirements. We can always look at ENVI Machine Learning help, but the steps for this tutorial are tested with ENVI Deep Learning 2.0, which is one of the newest ones. Actually, it's the newest one. It was tested on an Intel Xeon. I don't think I'm working with that. I have an Alienware PC, which is a little bit older, an Intel processor, but it still works. Intel CPUs are recommended for performance gains due to the Intel libraries. Okay, that makes sense. It's not required, but we should see a little bit of performance gain using Intel. For the files, what we want to do is go to ENVI tutorials, and it looks like it's hyperlinked here. So I'm going to right click this and say copy link. And right now, I'm just going to get in here and make sure. Okay, so we're just right back to tutorials. And on the right-hand side, I'm looking for deep learning right here. And it's going to download ENVI Deep Learning tutorial data. And for brevity, I just went ahead and downloaded this and unzipped it. It's going to come zipped. But now that I look at the hyperlink for it, it looks like we're hosting it on S3, Amazon, AWS. Okay, so that's where it's coming from. I'm going to go back. Click the deep learning link. Yeah, I did that. Extract the contents. Files are located machine learning supervised. Okay, we'll open that up when we get there. The imagery is from National Agriculture Imagery Program, or NAEP. They are public domain, so we can use them. Subfolders contain images used in this tutorial is 2 images for classification. That would be under the classification folder. 2 images for training under the training folder, and each training image is a subset of the 2 images of the classification subfolder. Okay. That means we're going to train on smaller versions, but then classify the larger image. They're 4-band, red, green, blue, near infrared, with a spatial resolution of 1 meter. Machine learning does not rely on any specific format. So for this tutorial, we're going to use TIFF and ENVI. All right, so I see TIFF from Dallas. It's about a 4K by 4K image. We have some labels for man-made trees, ground, and water. Okay. And then we have more. We have probably 5K by 5K image, more labels for Dallas and San Antonio. Okay, these are the larger images. These are for classification. We're training on smaller images at 4K by 4K. A little bit of background. Supervised learning is a subcategory of machine learning. This type of learning relies on categorical class labels in order to produce a function or model to identify learned classes and imagery. There are two types of classification problems: binary classification and multi-class classification. Binary is as in, is it this class or not? Multi-class is what we have here. If I scroll up a little bit, it says that we're looking for man-made materials, trees, ground, and water. That's multi-class. This tutorial focuses on multi-class classification in an urban setting using the labels we just talked about. Multi-class refers to more than two classes. Binary consists of only two. Okay, I got ahead of myself here. I was going to explain it anyway. By the end of the tutorial, we will have a custom reusable workflow for data preparation and training with multiple rasters. And here's the juicy part. This is ENVI Machine Learning, tells us that offers low-level tasks for data preparation and training. There are also higher-level tasks for single image classification and the machine learning labeling tool. This tutorial guide us through building a custom workflow using ENVI Modeler. I love ENVI Modeler. That's going to be fun. I'm excited about this. It will allow you to produce an easily modified ENVI workflow using ENVI Machine Learning. In this tutorial, all training data is pre-labeled. This will allow more focus on the tools and how to produce a machine learning workflow. And it looks like we're starting already. It says that ENVI Modeler is a powerful visualization tool for creating custom workflows using ENVI tasks. ENVI Modeler uses visual building blocks, which is analogous to writing tasks API code. Following is the workflow we're going to use to create the model. We're going to use file nodes and prepare the data and then connect that to a training node. We're going to add input parameters, run the model. Okay. So now what we want to do is start ENVI. Okay. So I'm going to get that up. And I have it up right now. And we want to open the modeler with one of the following. We can either press Control M, which is a shortcut, or we can go to Display and then ENVI Modeler. And then you notice when I hit Display ENVI Modeler, it said it tells you the shortcut. So it's gonna query all the tasks that we have in ENVI Modeler. And then a nice little blank window comes up. And the first thing we want to do is double click or click and drag file from the basic nodes list in the untitled area of the ENVI Modeler. All right, so under basic nodes, here's a file node. And I'm going to drag that into the untitled area. Untitled just means it's not named. It's not a named model yet. In the select type dialog, we're going to click raster at the very top. And we have a little raster node back here. And you might not be able to see this because I'm not sharing my Windows Explorer. But what I'm doing here is I'm going to navigate to where I have the tutorial data. And that is going to be deep learning object detection. Oh, no, that's something different. It's from my my previous adventures. I have ENVI Deep Learning tutorial data that's unzipped, and then inside there's several folders, but what I'm looking for is Supervised. Open that up. And then there's training. And then NAPE Dallas, Texas, October 11th, 2020 subset.tiff. That one's easy to find. That's the only TIFF inside this image, and I'm going to click open. And instead of the image opening in ENVI, it's just going to attach itself to this file node. What this does is it basically hard codes this node to that file. We're going to drag another file node in here. And then what we want to do is tell this it's going to be a regions of interest node. And then We should be in the same like file structure on Windows Explorer. So I'm in the same folder and I want to check NAPE Dallas, Texas, October 11th, 2020 subset.xml. Okay, hit open. And now this new node is going to say, oh, wow, I didn't know I haven't been sharing. Hold on 1 second. Here we go. Here we go. We're going to do this on the fly. And that window is called, there it is. All right. It's the magic of media creation. And let's see. We have region of interest. 2 file nodes consist of a raster image and ROI labels. Both are needed to generate a single training raster in the data preparation section. To keep organized, you can move the nodes in the untitled node canvas as needed. Let's move those around real fast here. To do this, click and drag a single node or click in the empty and untitled draw area and draw the cursor over all the nodes you intend to reposition. Okay. I'm just moving things around, get them all prepped for me. Select nodes. Selected nodes change to a lighter color. And we can see that a little bit. Repeat the 2 previous steps using the raster file NAPE San Antonio and the ROI. Both files are located in the tutorial data folder. Okay, when we're finished, we'll have 2 raster file nodes and 2 ROI nodes. All right, so it's not too bad that this wasn't showing before because I'm basically going to do it again here. I'm going to add a file. And then I'm going to bring in raster. And then I'm going to set this to San Antonio 2020 subset. Here's my San Antonio. And then I'm going to bring another file, and that's going to be region of interest. And that's going to be the San Antonio region of interest that's associated with this image. So I'm just going to bring that, I'm going to put them right next to each other. Make them pretty. Okay. What's next? Now we're going to prepare the data. To create training data for supervised classifier, we're going to extract the labeled pixels using the raster and the associated ROIs. You will use the ENVI machine learning ML training data from ROIs task to create the training data. This task will extract all labeled pixels from the raster that are identified by the ROI specified in the XML file. A new raster containing a single row of spectra will be created. Dimensions of the training rasters are rows equals 1, columns equals input. Rasters columns and bands and input raster bands plus 1. Okay, dimensions. The additional band will provide a numeric value per pixel. This numeric value represents the class label value per pixel. Okay, a lot of information. This is about ROIs here. For this tutorial, we have the class labels, man-made, trees, ground, water. These labels resolve to class values of 0, 1, 2, and 3. Okay, this is what we're talking about. It's not going to say, in the classification image, it's going to have the appropriate names, but in terms of, passing numeric values, each one of those labels has a numeric value instead of a string. Okay. So what we're going to do before I go on is I want to view some of this stuff. So what I'm going to do is I'm going to make this a little bit smaller. There we go. And over here, I'm going to move this a little bit out of the way. And I'm going to add a view node to each one of these ROIs and rasters. Let's see, view. Actually, let's just run the view node real quick. There we go. So we're just viewing that Dallas, Texas image. And I'm going to bring this out of the way, or at least turn off that window capture. And now I can kind of tell that the image came in with red as blue. So what I can do here is, if I go to change RGB bands, I'm going to say red, green, blue. Let's see what that does. And that should be, yeah, there we go. That should be the correct band placement. And then it says we're projected UTM zone 14. And then what I want to do is get rid of this image. I just want to see what it looks like. Actually, let's see if we can view. Let's view the ROI. So we're in Dallas XML. And what I want to do now is load the data. And then if I zoom in, I'm going to have pre-built training ROIs for red is ground. Purple is man-made, so that's over the road. We have water over the lakes. And then we have man-made over, there's a few houses in here. And then trees. But as I zoom out, we're not labeling that much of the image, and they're squares. They're not, rectangles. They're not highly complex ROIs. And it looks like this didn't take all that much long to generate. Okay, I'm just doing a little bit of spot checking. Remember that we have 4 bands. Okay, I'm going to get rid of this. And you can't see my data manager, but a little data manager comes up. I'm going to close that. And now what I want to do is open our other image. Just doing this for exploration, just to make sure what we're doing is, makes sense. This nape image comes in as red, green, and blue. And that, if you notice on the left-hand side in the layer manager, that this aerial image actually has the wavelength information. So it says red is 635. This is pretty uncommon for aerial imagery to have the wavelength information, but this one apparently does, which is good. So this looks pretty normal. And now what I want to do is go in and add the XML file for this image so we can look at the labels. And again, we have same classes, and I'm just seeing little tiny rectangles in here. Okay. And I can do things like calculate the statistics of each ROI just for information on whether we're capturing enough pixels. A good rule of thumb is to have enough training for your machine learning model. And a little bit of information is that each pixel is considered a training point. So when it comes to numbers, if somebody says, I want at least 1,000 samples, if I right click this ground region of interest inside the layer manager, and I'm going to add another little window capture so you can see. There we go. That is going to be the statistics. And it says that our pixel count for ground in particular is 5,964. So we have 5,000, close to 6,000 training samples on this one image for ground. Okay. And I can do the same for the rest of the ROIs. But for now, I'm going to get rid of some of these images. And then I'm going to bring up, now we have our data manager here. Okay, I'm going to turn that off for now. And then the other thing that we want is we're back in our modeler. And the next thing we want to do is search for ML training. Okay, so under tasks, in the little search bar, I'm going to input ML training. I'm going to spell it right. So there we go. Train. We have two things here. There's ML training data from ROIs and from spectral library. We're going to use, I assume, ROIs to generate training data. ML training data from spectral library is another machine learning data preparation task, which uses spectral libraries to collect pixel data for training, which is a little bit different. It's that's actually a pretty powerful little tool that that you can input just a spectral library instead of having to go through and manually delineating a bunch of ROIs. So we're going to double click on ML training data from ROIs twice. All right. And it says twice because I assume because we have two different images. So I'm going to add two nodes. Perfect. And then I'm going to make this a little bit larger. And that should be visible on the canvas here. And then we're going to arrange these nodes so they're paired to the right of the raster and ROI file nodes. Okay, so I'm going to do a little bit of rearranging here. I'm going to take this view node out. And then here's the raster and ROI pair. And then I'm going to move this task right next to it. Okay. Raster and ROI for San Antonio. And then move my task here. Now what we want to do is drag a connector to the raster node, or from the raster node to the ML training data from ROI. All right, so if I move this over a little bit, from that little triangle on the right-hand side of the data node or file node, if you hold the left click, you're going to have a little phantom-looking line, right? And if I connect it to the left-hand side of the task, what that now does is it tells the ML training data task that this is the input image. So if I open up this little, I call it a hamburger, it's going to say the input raster is that image. If I got rid of this line, it wouldn't know what the input raster is. So if I open this again, there's nothing, right? Let me do this again. And I'm going to change this window capture to the, there we go. This is what comes up. Input raster is blank now, but if I add my little line and then I open it back up and change this over to ML training. Let's see. I'm on capture 2. Just give me a second. Here we go. We got ENVI modeler, capture 2. There we go. Now at the very top, it says input raster. It already says that it's Nape Dallas. Okay. I'm going to close that. Now what we want to do is click and drag the ROI node to the same task. And what that's going to do is, since that ML training data task wants an ROI, we're supplying it now. Be sure to pair raster and ROI nodes correctly when connecting to ML training data from ROIs. Okay. Scroll down a little bit. Let's see. I can switch back here. So we're right here. So we have repeat the previous two steps for the remaining raster and ROI nodes. Once all nodes are connected, you should have the following. Okay, I'm looking pretty close here. I'll switch back to my ENVI. And for the second task, connect these. And I can move this around now, make it, symmetric. There we go. And let's go back to our instructions and the task search. We're going to type normalization statistics and then double click that. Okay, so what this sounds like is that we have this thing that does training data from ROIs, but once we interact the ROIs with the image, we want to do normalization. So I'm going to type in not all of normalization because I'm sure there's only so many nodes, but we have normalization statistics. I'm going to drag this in. Let's see. Do we have to do 2 of them? It just says 1 here. I'm going to put that there. And then from basic nodes list, we're going to double click an aggregator. And that's going to add a little orange aggregator. And what that does, it's like a bucket. So when you produce outputs, an aggregator is going to collect all of that information or data or processes into an aggregation bucket. So now, let's look at this here. We're going to click and drag both raster node connectors onto the aggregator. Okay. And then we're going to click and drag the aggregator connector onto the normalization statistics. Okay. So let's see. That's going to, before it even goes into the ML training data, we're going to bring the aggregator over here and we're going to connect both images. Actually, let me get rid of the first connection. Whatever you add to it first is going to be the first to be processed. And, I haven't read ahead so far as to see whether this matters in terms of order of operations. So we're going to collect the 2 rasters into a bucket, and then we're going to perform normalization statistics on those 2 rasters. Okay. And then this is what ENVI looks like now. I'm going to bring that over here. And then it looks like we need to do something like this. So we're going to add the output of the normalization statistics. Let's see, like I said, if they're out of order, I'm not sure if it matters right now, but I'm going to go back. The output of normalization statistics into ML training data for each one. Okay. It collects the minimum and maximum data values from an aggregate of input rasters. It's important because the data will be scaled between 0 and 1, like reflectance, using the minimum and maximum values. Okay. Now, let's see, move over a little bit. To train with output data produced by ML training data from ROIs, we're going to need to aggregate the training data and connect it to a training task node. All right. So we are just now getting to ML training data from ROIs. And now we need to add the trainer. Okay. So we're going to use the train random forest task. But you can select any of the supervised classification tasks. Okay. I think because this tutorial is set up for random forest, I want to make sure that we are, here it is. I can double click that and it's just going to pop up normally. Get back to ENVI. So I found train random forest and it looks like we're going to probably want to put it over, to the right-hand side of our ML training data ROI so we can kind of get things going here. Go back to our instructions. All right. We're going to get another aggregator. Okay. So apparently we double click the aggregator. Okay. And then we're going to connect both ends of the ML training data from ROIs to the aggregator. Okay, we can do that. Move it around here. It's starting to make like an interesting little picture. And then it says our ENVI modeler should look similar to this. And if I go back, it looks like I don't have my random forest connected. We'll do that. Go back to the instructions. The input parameters is a basic node that we reuse. It's reused by many nodes. Input parameters nodes will be connected to multiple nodes on the canvas. It's basically, it's kind of like a file dialog when you don't want to hard code an image or ROI, it's going to ask you what you want to use. So an input parameters node, it's going to be a little pink node that comes up. Very useful when you want to make a model in ENVI that is universal for any type of data. So we're going to add an input parameters node. Okay. Double click. Little pink guy comes up here. And we're going to add that to one of the ML training data from ROI's nodes. Okay. Let me get back here to my browser and put it up at the top. And then I'm going to connect to it to one of the ML training data ROIs. So what that's going to do is, let's see. I'm going to pause a moment and make sure that I can get what happens when you connect the input parameters. Okay. So it's going to ask, all right, we have this new input, but what do you actually want to input? And we already have the training raster. We have the input ROI. And it's starting to sound like maybe background labels. Yeah, okay, here we go. We're going to connect the background labels button under ML. A red line connects. Perfect. So as soon as I hit, instead of hitting add new input first, I'm going to hit background labels, and then it's going to automatically look at the left and say, oh, this is what you want. So what this is going to do when I hit OK, when I hit run, it's going to get to this point and say, what do you want for background labels instead of like hard coding it? Okay. So I'm going to click OK. Now, do we need another one? Repeat this step. Perfect. Okay. So I'm going to add another input parameters. Or no, I'm going to, you can only have one. So I'm going to get rid of this window capture because it's duplicated. What we're going to do is connect that first input parameter into, yeah. All right. All right. So let me get this up to show you the difference here. This is connect parameters. Okay. So now with the same input parameters node up at the top, I connected it to the other ML training data from ROI. And at first we just had add new input, but now it's saying, do you want the input parameters from that first node to be the input for this second node? And that's what we're doing here. So I'm going to connect background labels to background labels. So it's like a kind of trickle down effect here. And then I'm going to hit OK. And then we're going to connect the input parameters node to the random forest node. And then in the connect parameters dialog under train random forest, we're going to click estimators, balance, max depth, and output ROI or URI. Okay. So let's see. I'm going to connect input parameters to random forest. And it sounds like for add new input, I'm going to say estimators, balance classes, max depth, and output model URI. URI is just basically a path of where this is going to get stored. All right. That's what this looks like. I think I can hit OK now. So go back to our instructions. All four parameters are connected by colored lines to input parameters. And ours look just like that. Okay. We're doing a lot with modeling here. I like this. Your model should now resemble the following image. All connections are complete. Note the connection to train random forest node from aggregator node in the input parameters. Okay, so it doesn't say this in here, but the way this looks, let me go back to ENVI. And if I move this around, I can make it larger. Here we go. Make this at the forefront. So the way to get it to look how it looks like kind of like a spaceship maybe is in ENVI Modeler at the very top, it's going to have a 4 window type situation icon, and it says automatic layout. So if I hit automatic layout, it's going to go through and say, okay, this is connected to that. This is connected to this. And this is how it thinks everything is connected. Okay. Now it's going to say in the instructions that we're going to run the model, and it wants us to save it. But real quick, I know another trick in here, just in case. We have validate model, which is Control plus F8. But if you go under code, it's not showing the very top of ENVI Modeler, like the menu. But in the menu, context menu, it's gonna have code, and then the fourth one down is validate model. And it says my model does not have any errors or warnings. Okay, that's perfect. All right, so the thing that kind of worries me is this is what my model looks like when you do an automatic layout. But if we go back to our training document, it looks like it's nice and connected. Okay. But it, I don't know if that's from automatic layout or that was done manually to make it look like that. But let me go back. If I go up, this is input. This was into train random forest. That's okay. So I guess I wanted to check that one part real quick because I have two connectors going into train random forest over here. And the way it's set up on my ENVI is that I can see two, but in the instructions it's one because it's like linear. They're connectors over connectors, right? So the next thing we want to do is from ENVI Modeler menu bar, select File, Save As. And like I said, my Windows Explorer isn't coming up, but I have a little select output model file, and I'm going to put that right where my training data is. Let's see. I have ENVI Deep Learning tutorial data, and then in Supervised, we need to call this tutorial.model. I'm going to call it something else. I'm going to call this Supervised _ random forest .model. Okay, and hit save. So now our little tab at the very top has been updated and it says Supervised random forest. Let's go back to our instructions here. From the ENVI Modeler toolbar, we're going to click Run. And then the tutorial task dialog appears with 5 task parameters. Okay. Let's go back. We're going to hit Run. That's this big button up here. I'm going to deviate from this a little bit. And you see, instead of Run, I'm going to go back to Code. And I can run model, which is F8. Or I can hit Run Model in debug mode. And then you can see that, let me get some of these little windows up here. This is going to be, it's not that. Interesting. I don't know if I can get this one up here. All right. Interesting. I apologize. I have a little window that doesn't want to show up. Okay. Anyway, if I go, I'm seeing the same thing in what the tutorial data is showing, right? I have a little tutorial. Of course, I named it something different. It says background up here, estimators 100. That sounds like a default value. So it looks just like this on my screen. Click the help button in the lower left of the dialog and the tutorial task appears. All right. And then says a little bit about what we're giving as the input parameters, string arrays and uint for estimators. Max depth. All right. Specify the maximum depth of the tree. Interesting. And we can read through that, or we can close it. In the background labels field, we're going to delete background text. All right. I got rid of that. And then let me go back here. We're going to leave this field empty. Optionally, you could enter any 3 or 4 labels during the labeling process. For example, if you wanted to identify only trees, you would add labels man-made, ground, and water. Okay, I got it. So because it's background, we would put in the things that we're not really interested in. Okay. And then if we did that, this would produce a binary classifier with labels, background trees. Okay. Leave the default values for parameters, estimators, balance, classes, and max depth. All right. And then we're going to click the browse button next to output URI. And we can do that. And it sounds like we just need to like name our model, and that looks like it's going to be a JSON file. So I just hit that button. Like I said, it's hard to show all this stuff. I'm using OBS. We don't want to have anything in the background labels because that's optional. Let's see. With all parameters specified, we're going to click OK. And then the ENVI modeler nodes change color to green, showing the completion of each step. So let's go back to ENVI. And then I'm going to hit OK here. A training progress dialog appears during the training step. All right. Oh, there is a little execution report. I thought that would come up. Oh, we're done already, right? Let's see. Execution report. Where did that go? There we go. This is going to say how long it took and what it did exactly. It says total execution time is 3 minutes. But the training was only 11.7 seconds. So it's adding some kind of other time in here, but it's actually, our training did 11.7 seconds. Maybe it's the time that I took to mess around with some of these windows here. But that's what you get. This little execution report is what you get when you say run in debug mode. Okay. And then if we go back to our instructions. All right. We have a model now. So now with the trained supervised classification model created, you can run the classification process, minimize or close the ENVI modeler, and then we're going to use machine learning classification task in the ENVI toolbox. Okay. So I see here in my ENVI, I can go ahead and close this. And what I want to do is I have this saved. I'm just going to go and close there we go. And I'm going to have a bunch of little windows come up here because they're taking over. And now what I want to do is from the ENVI toolbox, I'm going to look for machine learning. And then we're going to double click on machine learning classification. And then once again, my window doesn't come up, but that should be, Okay. I can see it. I just can't bring it up in OBS, but it looks like what we have on the screen here, input raster from the ENVI toolbox. Okay. Now what we want to do is click the input raster. So this is going to be one of those larger aerial images. And so we want to we're going to click the open. And then we're going to bring in Dallas, and that's under classification. Okay, so we're going to get out of training, go to classification, and we have a Dallas.tiff. Okay. And I'm going to hit OK on that. These are 4 band images. And then in the input model, I'm going to go and find that urban.json. And I put that in my training folder. And then in normalization, let's see. Leave the normalized fields empty because we did that in the model. Leave the output raster field blank. A temporary file will be created and displayed after classification completes. Okay. And then enable display result. And that's just going to pop it into ENVI proper. Okay. And then it says the classification completes after 30 to 60 seconds, depending on time. We'll see how fast my computer is. And then one last ditch effort to see if I can get machine learning class. Yeah, perfect. There it is. So I got it here. Nothing in normalize. I have my urban.json. And I'm going to hit OK. And a little processing dialog is up now. Executing random forest. Should I start timing it? Let's bring up clock. And then we're going to give it, we'll give it like 10 seconds as I messed around to try and find this. Still going, still going. So as it's processing, I just want to kind of talk about what's happening right now is we already had ROIs, and then we brought them into that machine learning training with ROIs task. And we did some like normalization with the imagery. And then we trained a model. And now we're taking that urban.json model and applying it to a much larger image. And then what we're going to get is those 4 classification types of man-made and water. And the idea here is that it should be fast. And also you have a model that you can now share with other people. You can leave it on a server and have it applied to any new imagery that comes in. And you're interested in finding those classes. I'm at a minute in 30 seconds. So maybe my computer is a little bit old. I'm not sure if I want to go out and buy a whole new one just to save a minute, but it says I'm about halfway done. We can sit in silence here. Or you can pause and allow your computer to crunch the numbers. If we go ahead while it's running, the classification raster displays in the ENVI view. I'm not there yet, but the layer manager shows the classes unclassified, water, ground, trees, and man-made. Sounds right. The class unclassified was not used during the labeling process, so this class represents any unclassified pixels. Okay, so it's not necessarily background. It's just not one of those classes. The colors used for each label during the labeling process are also the colors used to identify the targets. So we expect to see, well, we saw purple for man-made and probably blue for lake, green for trees. And then as soon as that is done processing, I'm going to open up the data manager and load Nape, Texas, Dallas, Texas, and load default. And then we're going to want to move the machine learning classification output above the image. And then I bet we're going to do some kind of transparency or something here. Or maybe we turn off unclassified. Yeah, on transparency. From the ENVI toolbar, we're going to move the transparency slider back and forth to explore the classification result. Okay, I'm done. So let me go back here. Here's my ENVI. And then machine learning classification result just popped up. And on the bottom right here, it says that we're building pyramids for this classification image. Okay. So if I remember back, I'm going to go to my data manager and see if I can bring this up in OBS. That's going to be data manager. There you go. And then if I right click this and say load default, I remember that this one comes up without the band combination. So what I really want to do, actually, I'm just going to get rid of this out of my layer manager. And then I'm going to say red, green, blue for Nape, Dallas, Texas, and say load data. And that should be true color. So it looks like the other way around is that thought band 1 is blue. And normally you would think that blue, green, red, near infrared. For some reason, this 4-band imagery, the red is band 1. Okay. And now what we want to do is take the machine learning classification and bring it up to the top in layer manager. And then over on the right-hand side, this is the transparency slider. Let's say, let's zoom in a little bit and see if I can find an area that kind of has everything. Let's see. Okay, here's a big water feature. Let me move the data manager out of the way. And then I'm going to slide transparency. All right. And it looks like, okay, there might be like a little hiccup here. I think the water here looks good. Maybe a little bit of salt and pepper in the classification. Red is ground. I think for the most part, that's decent. But I noticed if I come up here, there is what I know is a lake. But that was classified as man-made. And I don't think it thinks it's a man-made lake. So and then we're supposed to focus on this football field. All right. So it's saying that the grass on the football field more resembles water. Instead of, let's see here. I got another thing here. I'm going to turn on my cursor. And if I bring my little red cursor down here, and it's unfortunate that it's red, but that is showing as man-made. But then the field over here is showing as trees. So it has some kind of IR signature. All right. Okay. I can spend a lot of time looking at this. But if I go back to my browser, it's going to say that we're going to notice that the model did a pretty good job at identifying the correct classes, but it's not perfect. Shadows throughout the image have been classified as man-made. One way to try and eliminate this would be to create a shadows class, yeah. Or collect shadows as part of the background class. Another imperfection is the football stadium that's partially labeled as water. This could be mitigated by adding labeled examples of the stadium and retraining the model. So we're going to enter pixel coordinates 7784P. The P just means in pixel coordinates. And then 7148. And that's, I'm there already, but what I can do is I'm going to add 7784. Actually put the 4. And I think if I don't put this in here, I think it's going to know that it's pixels. Yeah, there we go. Okay. So we're centered on the field. Optionally, we can run through the classification workflow again to see how well your model does with the additional classification scene. The image can be found in the tutorial. Oh, the additional classification. Oh, perfect. Got it. And then, wait a minute, we're done. We're not done. All right. What we're going to do is let's just turn these off in the layer manager. And now what we're going to do is double click machine learning classification. And then here we go. In the input raster, I'm going to go and find under classification, we were using NAPE Dallas, but now we're going to use NAPE San Antonio. I'm going to hit OK. That's 4 bands. The input model, I'm going to go find that under training. It's called urban. All right. And we didn't put anything in normalize. We didn't put 0 to 1. Output raster was a temporary file. So I'm just going to hit OK and let that run. So let's see. Oh, this makes a lot of sense. So the training of the model actually didn't take that long. What was it, 11 seconds? This is the classification, which sort of makes sense. It might take a little bit longer to classify. It's a bigger image. It has to evaluate each pixel against the model to determine an entire classification image. That makes sense that it would take longer. So this is running. And we can look at the new image when that comes up. Let's see. I think I had my clock running arbitrarily here. 10 minutes. If I'm lucky. Oh, you know what? I think OBS just takes a while to get a window up. Maybe it has to poll, I think. Like, all right, what's on the screen? What's on the screen? All right, it's running. I can bring up my cursor value. There we go. I don't know if that helps. No, it doesn't. Here's machine learning. There it is. All right. So I can move this, make it bigger. There we go. What else can I get? The data manager. That's here. All right. Just give it time. Let's see. What do we expect? We saw confusion with water and man-made. But I think overall it looked to have found all the roads. And I didn't see any wild things going on with the trees. I think for the amount of work that we did, like of course we didn't make the ROIs, but they look pretty fast to generate. We haven't spent a lot of time with the training and the classification process. And if you've done any supervised classification in ENVI or anything really, that you might think it's a time-consuming process to be able to have ROIs that are statistically representing the classes you're interested in. So I'm still running. Looks a little distorted as I made it super large. See how large I can make it here. There we go. Whoa. There we go. And we can always take the time to use different classifiers. We didn't train like a random... let me take that back. All right, this is a really large data manager. So now what we have is because it's a different area. Remember, it was San Antonio and Dallas. In the layer manager, all I have to do here is say zoom to full extent. And now we have the classification image, but we don't have the actual image. So what I want to do is this, no, this is San Antonio. I have it in my data manager already. Let's turn that on. And now what I want to do is if I say load true color, because the San Antonio image has wavelength values, that's going to look fine. And you know what else I can do is I can actually say load CIR, color infrared. Looks like a color infrared image. Okay. And instead of dragging this up above the nape, what I can do here is if I right click that layer, the classification layer, I'm going to look for something like, let's see, order. And then if I say bring to front, it's going to bring it to the top. All right. And I remember one of our tricks is to use the transparency slider. And this works because I have the classification result highlighted in the layer manager. Okay. Let me zoom in. I see this lake here and then a river. Wow. Look at this lake. It's almost the same color as the ground, but I bet you it looks a lot different in infrared. Yeah, okay. That makes sense. It actually, you know, maybe we would have a hard time if, let's see the transparency. Okay, we might have a hard time if we just had 3 bands. But it looked like it worked. Let's see, we got a river, we have contiguous, like adjacent pixels. It looks like we had a little hiccup with the water up here. And maybe we just need to do more training. I mean, every lake is different. I'm not seeing, you know, like a real wild amount of speckle. You know, like individual pixels. Except right here. You see this? There's a lot of man-made interspersed with this red class, which is ground. And you know what that is? That's shadow. Okay. Mostly shadow, I'm going to say. So we might want to go back and add a class for shadow, which wouldn't be too hard. I mean, I can see huge shadows right here. And these overpasses and then these larger trees. What else do we have? Actually, there's like a little bit of transparency, so it kind of made it look interesting. Kind of looks like a saturation effect here. But it really just looks like this. I think overall we're doing pretty good. We have, you know, I could say that we might be 90% the way there. And it really just we just kind of need to go back and add some of these classes that are confusers and as their actual individual classes, because we can always turn them off. And it's kind of funny. We talked about having an unclassified class. Let's see. But the only unclassified I see, I was hoping for, you know, for shadows, they might be unclassified. But the only unclassified class I see is at the very top. Is that real? That's weird. Maybe this is no data up here. I can figure this out here. No data. It is no data. All right. I want to be able to bring this up here. So I have a little cursor value and I'm going to turn this on. It's a little large now. Interesting little tidbit about this image. I just want to talk about this real quick. But if I move my cursor value outside of this image, there's no value, right? But if I go to where this like little light blue is, it says there's no data. There's some kind of weird padding on this image. The machine learning thinks that that's unclassified, which it could be throwing off, our ability to have an unclassified class based on the data. So that's what I'm going to say towards the end of that. I'm going to turn some of these things off, and I'm going to say that that is supervised classification with random forest machine learning. And that's one of the L3 Harris's newest tutorials with ENVI. And I'm super excited about machine learning. It looked, it felt pretty easy to go through that. I want to spend a little bit more time trying to see what the class confusion, how I can mitigate that with extra training, perhaps. But stay tuned for more ENVI tutorial videos, and I'll just work myself backwards, and then maybe we'll look at supervised, and then we'll get into hyperspectral and LiDAR. But be sure to check out one of my very first videos is deep learning pixel segmentation, which looks at various damage with pixel segmentation deep learning. And that was a fun one to do. Anyway, thank you. And if you ever have any questions about how to do some of these things, you can email me at jp.metcalf@l3harris.com. Thanks.